Our today's topic is multithreading in Java. So, before we talk about multithreading, we need to know what is thread. So, we can say thread is nothing but a process, and we can say lightweight process is called thread. So, now you need to know what is process. Suppose you have written a program and that code is saved in your disk. Okay. So, you can say that is a program, that is not a process. Whenever that program is running, that means taking some CPU time or getting some CPU time, that time you can tell one process is running. Okay. So, process is nothing but program in execution. I hope you understand the difference between the process and program now. Okay. And what is thread? Thread is nothing but a process, a lightweight process is called a thread. Okay. That means I have used one term here, lightweight, and whenever we will be talking about process, we will be telling process is heavyweight. Why? Because whenever you create some process, it takes some memory area. Okay. Now you want to create a child process. That child process will take another set of memory area. Okay. And if again you want to create another child process, that will take again another set of memory area. Okay. But whenever you will be working with thread, the parent thread, whatever memory area it is using, whenever it will be creating some child thread, that child thread will be will be in that memory area where the parent thread lies. Means whatever memory area parent thread is actually consuming, child thread will also consume that much memory area. So, the number of child thread, number of increment of child thread is actually not taking much memory, because whatever memory your parent thread is taking, within that thread your child thread is being created. Okay. But in case of process, parent is taking another set of memory, child is taking another set of memory, and the number of child increase. So, memory is also using of memory area is also be increased. So, that is why process is what? Heavyweight. And what is about thread? Thread is lightweight. I think you have understood, still I am telling you once again. See, this is suppose your memory. Okay. Now, this is your parent thread. Okay. Whenever this parent thread is creating some child thread, suppose that child thread is taking this memory. Again, when this child thread is creating another two child thread, those are taking different memory areas. So, you can see that the memories are getting filled by the child process, but in case of thread, suppose this is the memory and your parent thread is taking this much memory. Okay. Whenever this parent thread will be creating some child thread, that will take memory inside the parent. Again another child when will be created, it will be taking the memory that is inside the parent thread. That is why your parent thread is lightweight and child thread is process is heavyweight and thread is lightweight. Right. Now, we need to know what is thread. So, first we will talk about single thread. Single thread means one task at a time. Okay. And multi-thread means many tasks at a same time. Suppose we are developing some game and that game is having 3 cars. So, in the single thread model, one car only can run at a time. You understand? And in multi-threading, your all cars will be moving at the same time. Right. So, for gaming actually this threading concept is very important for gaming app like NFS and all. Now, we will be talking about multitasking. So, what is multitasking? Multiple tasks and at the same time, that is multitasking. Suppose you are executing more than one task simultaneously. Example, suppose you are listening song, at the same time you are downloading some application, at the same time you are doing Java program. So, multiple tasks you are doing simultaneously. So, this is known as multitasking. And what is multi-threading? Multi-threading means when executing more than one thread at the same time, that will be known as multi-threading. That means each and every thread is separate individual by independent part of the same application. You understand? Multitasking means different application are running at the same time, and multi-threading means within a single application many threads are going to run, or many different individuals are going to run. Like you have worked on Microsoft Word, right? In Microsoft Word, you have seen that whenever you are writing something, your spelling check has been done, okay, your grammatical check is being done, and sometimes you can see your content is being auto saved. Suppose there is no multi-threading concept, so what would happen? First you need to write the thing whatever you want to write in Microsoft Word, then you have to check the spelling, then you have to check the grammatical error, then you have to save it. So, how many times it is taking? For a single work it is taking 4 unit of time, right? Now, multi-threading concept is there, so you are writing, while you are writing your spelling check is being done, your grammatical error is being shown, and your document is being auto saved. So, I think threading concept is clear, isn't it? Now, look at the slide. The thread is smaller, lighter than a process. Whatever I just told, that has all thing has been written here. So, today I will not only be talking about the slides, I will be doing some examples also, because for exception handling and for thread I need to write few programs for you to understand much better way. Okay. So, I feel you have now realized what is task and what is thread, what is multitasking and what is multi-threading. Okay. Now, thread is a single sequential flow of control within a program. Single threaded program can handle one task at a time. All this I have already discussed. This is one example that is there. Suppose you do you have the concept of client and server? Client and server both are actually two machines, means two PCs, right? One whatever PC you are using for your work, that is client, and suppose I want to open my Gmail account, right? So, my PC is now client, and whatever server is having my ID and password stored, that is the server that is called the server. So, suppose if there is no multi-threading concept, so when I would logged into my account, you would not be able to log into your account, isn't it? So, that kind of one example has been given here. Okay. So, why we use thread? That is the main question. Why? Because we want to increase the CPU consumption, means we want to increase the working capability of CPU. We do not want our CPU to be idle. So, as much as work it can do within a single unit of time, that means your CPU is that much capable. So, we do not, our CPU is very much capable. So, we do not want our CPU to sit idle. Okay. So, and also if you are thinking about server, your server also can handle multiple clients and simultaneously, right. Again, why we need thread? There are few points that has been written. By the way, remember that you have to read books, you must read books. Okay. Again, some figure is shown that multiple threads working on multiple CPUs and multiple threads sharing a single CPU. Okay. Now, how we can create threads in Java? So, there are two ways. One is you can extend thread class, or you can implement runnable interface. I feel you remember the keywords extend and implement, isn't it? So let's take a look. Threads in Java, you want to extend thread class in Java. So create a thread. There are two approaches. Again, I am telling, extending thread class and implementing your runnable interface. Okay. Now suppose a single threaded model I want to create. So suppose let's take one example, class ABCD. System dot out dot println, system dot out dot println. I want to print just hi. Okay. So how much work is doing here? This is what? This is a single thread is running only, isn't it? Execution start from where? From the main, and one thread is automatically started, that is the main thread, right? So this is single threaded model. Now we will learn how we can extend java.lang.thread class. So the processor, there are few processes. Okay, the first is you have to create your own process, then you have to override the run method to write the logic. Okay, then the third point is you have to instantiate your thread, and fourth is you have to call the start method by your object. Let's take the example. So class what to say, my thread extends, so I have to extend the thread class I told. Okay, then you have to override the run method. So which class is having run method? Whom I am overriding? Thread class, right? And now I am overriding it. So I am putting my own run method, and now I am writing logic for my thread. Okay. So what logic? Just a for loop I want to write. Int I equals 0, I less than 5 suppose, and I plus plus, and nothing, just I want to do system dot out dot println, and I just want to print user thread. Okay, and that's my logic, whatever I want to run, and that's all about my thread class. Now I told you that you have to override the run method, and then the third is you have to what? Create the instance. So I want to create instance, so I am taking thread demo. Okay, that's my class name, and I want to write public static void main, so let's copy it. Oh, sorry, copy it, and then I told you what you have to do here. You have to create your thread classes object, right? So what is your user thread? My thread, and this is the object I am creating. Okay, so I have instantiated my thread or user thread. Now I have to call the start method to start my thread, and here I want to write logic for which logic for the main thread. Main thread is always running, right? So here I want to write some logic for my main thread, and let's see. Nothing I want to do, I just want to copy and paste it, and it's the main thread. Okay, that's it. Right. Okay, so let's compile it. Now the name of this program would be multi-thread demo. No, I don't want to override multi-thread demo 1.1. Right, compilation done. Let's run the program. See the output, look at the output. 5 times your main thread has worked, then user thread. See, this output is actually unpredictable, so it's coming the same output. Look the difference between two output. Look, previously all the outputs are coming main thread and user thread. Okay, now here one main thread, then 5 user threads, then again 4 main threads. So the behavior of thread is actually unpredictable. So again and again, if you will run, you can see the different type of output. You cannot predict. Okay. Okay. Now, if application contains more than one thread, okay, no, first you need to know that what has happened. Why you are using the main thread means what is the importance of the main thread. Two importance of main thread are there. First, your program execution is starting from the main thread, and the second is to start the user defined thread. We must depend on the main thread, because within the main thread only I am creating the object and I am calling the start method. Okay, so do you understand the program? Now, if your application contains more than one thread, here my application is contain only one user thread and one main thread. Suppose my application contains 3 threads, means more than one or 2 thread, then which thread will be the first thread to run? The execution will start from the main thread, that is okay, but after that which thread will run first? Now this decision of thread execution will be decided by the thread scheduler. Okay, thread scheduling, all this will be knowing in the subject operating system, but still I am telling you that thread scheduler is having, or they are maintaining few algorithms like primitive algorithm, time slicing algorithm, all are they actually following. So this execution of thread will also be decided by your thread scheduler, right? So which thread will be coming to first and which thread will be the second, which thread will come at last, that will be decided by your thread scheduler, right? And the thread scheduler is a part of JVM, right? Now see, I have called here start method, but is there any start method here in my class my thread? Means my thread class is having any start method? No. Then how can I call this start method? I can call this start method because start method is available in your thread class which you are extending, right? So when we call t.start, JVM search first in my thread class. JVM will start in which class? This class, this my thread class. It will search whether any start method is there or not, but there is no start method. So JVM will search the thread class, right? You understand? So your thread classes start is executed. That means your thread is registered in the thread scheduler. After this line, your thread is registered in thread scheduler. That means your thread is created. Let's take one example. Suppose you are there in a college called whatever college you are studying, that college first you have to register yourself, right? If you are not registered within college, you cannot study like that. If you are not registering your thread, you cannot make your thread start. So when we call t dot start, that means we are registering user thread to thread scheduler. That means your user thread will be, or your user thread has been created. Okay. And whenever you are calling start method, that start method automatically call run method, right? So the run method will be executed if we call t dot start. Got it? Is it clear or not? If any doubt, please write your message. Okay. Now whatever we have seen in this example, we have seen only a single thread and one main thread is working. Now I will be taking one more example where I will be showing you that multiple threads are doing the same task or single task. Okay. So let's copy a few portion of the program. Okay. Now public void run, and I want to print something. This much I want to run. Hi. Right, and that's all. That's all I want to write. Next, I want to create public class thread demo 20. Right. Okay, so again I want to copy few portion. This much I want to copy. Let's write it. Okay, now I want to create few more threads in my program. Don't get confused between these two, 20 and all. I feel you all know the difference. That's all I want to write. And so how much thread is actually there in my program? There is a main thread, first thread, there is a T1 thread, T2 thread, T3 thread. So 4 threads are running. And what is the name of my program? Thread demo 20. Let's copy it. Okay, and I want to run it. See, your 3 threads are now running. So how many threads you have created? 3, T1, T2, T3. And how many work they are doing? They are only doing a single work, that is printing hi, because every time it is calling the start method, that is going to call the run method, and within your run method there is only a single line that is being printed, that is hi. Okay, now your application is containing how many threads? 3 threads, 4 threads, your main thread and 3 other threads. Okay, so multiple threads here are doing the same work, and how many stack memories will be created, you know, there will be 4 stack memories will be created here. Okay, and now I am going to talk about, here you have learned that the same work is done by different thread. Now I am going to show you that a different task by different thread. Let's copy it. Let's get now this much class thread, my thread, let's take it my thread 1, and within the main method I want to write, this is my thread 1, this is thread 1, and let's copy the whole thing. Okay, Control V, and I want to create 3 separate threads, so just change the name. Okay, now after that I want to write the publish requirement part, so let's take let's copy the whole, and let's paste it, public class thread demo, thread demo, what should I write, my thread demo. Okay, now I am printing thread my thread, and the class name is my thread 1, so my thread 1 t1 is my thread 1, my thread 2, here also my thread 2, and now my thread 3, I'm going to write my thread t 3, right, and yes, so compile it, compiled, and see, look at the output, this is thread 1, this is thread 2, and this is thread 3, and now look at the change of your output, change in your output, 3 2 1, your thread 3 is working first, then 2, then 1, so unexpected behavior by your thread, 1 3 2, sometimes it may come 1 2 3, 1 3 2, and like that. Okay, first one is has come 1 2 3, then 3 2 1, then 1 3 2. Okay, so here you, what did you understand, that the different thread are doing different tasks, right. Now let's check what is there in our, so here I am writing a single very simple program. Now you can write a complex program, I think. And again thread class, all whatever I have done in my program, all that is written there. Okay, so implementing java.lang.runnable interface, that I am not going to talk about, or that okay, let's discuss first the thread states. Okay, so as you can see, this is the actually thread life cycle, which is very important for Java exam or object oriented programming by Java, this kind of papers, generally giving the thread life cycle or applet life cycle or both in your exam, so you have to know it. So first you can see there are 5 states. During the lifetime of a thread, there are many states it can enter, okay, including the newborn state, then the runnable state, then the running state, then blocked state and one dead state, right. Now, a thread is always in one of these 5 states. You understand? It can move from one state to another via the varieties of way, and it is showing. See, many names of methods are written there. So, suppose one thread, I am going to talk about now newborn thread. Okay. So, when we create a thread object, what you have seen in the program, when we are creating the thread object, the thread is in the born state, or you can say it is in the newborn state. Okay. So, you can schedule it for running using start method, or you can kill that thread by using stop method, right. Next is your runnable state. So, what is runnable state? It means that the method is ready for execution and waiting for the availability of the CPU. What do you mean by that? Suppose few threads that has come, that the request has come to the CPU, right. So, now CPU will decide that which thread will be running. Before the running state, they are waiting in a queue. So, that is the runnable state for your thread. Okay. Now, if you want a thread to relinquish the control to another thread of equal priority, we will be talking about later, just listen that means just you must know that who is having higher priority is getting the chance first, right. Like the same concept is here also. Suppose a thread of lower priority is running and some higher priority thread has come. So, the thread want to relinquish the control to another thread of equal priority or higher priority. Okay. Then what we can do? We can do that by yield method. Okay. So, from runnable to run, yield method. I am sorry, from running to runnable, yield method, because after runnable your method is running, right. So, relinquishing control, you have to use yield method from running thread to the runnable thread, right. So, what do you mean by running state? Running means that the process has given its time to the thread for its execution, means CPU has given or allowed your thread to run. Okay. Now, 3 situations here may happen. So, those 3 situations are shown here by the method name suspend, sleep and notify, suspend, sleep and wait, right. So, first we will talk about suspend. Now, it has been suspended by suspend method. One thread was running in the running state, and now suspend method can revived by now a suspend method has been called. So, what will happen? Your running thread will be going to the where? In the block state here. So, we have called the suspend method. So, your thread from running state to block state, it has gone. Is it clear? Now, again if you want to revive your thread from the block state to runnable state, then you have to use this resume method. You understood? First it was in the newborn state, then runnable, then running. Now, suppose suspend method has been called, so it will be going to the block state, then from the block state, if the resume method is called, it will be coming to where it will come to the runnable, then again from runnable to running. Clear this much? Okay. Now, the second method is sleep. So, previously I have shown you that whenever I am writing sleep method, I have to pass a time, that is in millisecond. So, sleep and you have to pass time as argument. So, we can put a thread to sleep for a specified time period using the method sleep, and you have to pass the time, but time is you have to write in millisecond only. Okay. Now, whenever sleep method has been called, your thread from running state, it is going to sleeping state. Okay. Now, after the time that has been specified here, suppose you have written sleep 1000, that means after 1000 millisecond your thread will automatically coming to the runnable state, and then from runnable to run state. Clear? Clear? Okay. Next, I need to talk about this wait method. Okay. It has been told to wait until some event occurs. This is done by wait method. When I want to tell my thread to wait for some time, because few things need to happen before that thread to be running, I need to, this work is done by wait method. This method can be scheduled to run again by the notify or notify all method. So, runnable to running, then you have called wait method. So, your thread is in waiting status, then from waiting you have called this notify and notify all or notify all, then your state thread is coming from waiting to runnable state again, then from runnable to running state again. Clear? This much clear, na? All the methods, whatever is it is written in the picture, all these things are clear. Okay. So, what is block state? Once I want to tell, a thread is said to be blocked when it is prevented from entering into a runnable state and subsequently the running state. A blocked thread is considered not runnable but not dead. Do you understand this line? That your thread, when it is in runnable means blocked state, that is not dead, but that is not in runnable, means that is not waiting to get the CPU time. Okay. Now, what about dead state? A running thread ends its life when it has completed executing its run method. So, whenever your run method has finished working, then your thread is in terminated or it is in the dead state. Okay. I think I should stop here for today's class, otherwise you will not going to understand the things. Whatever program I have written, you need to practice that more, and the next part will be in the next class only. Okay. So, again I am going to tell you that please practice all the programs. If there are any doubt, please write message to me, and that's all for today's class.